At the end of the previous video, I mentioned that in order for you to differentiate at a particular point, that point needs to be smooth and continuous. Now, what I mean by smooth, I will explain later. But if you look at this function here, remember continuous means the limit from the left-hand side equals the limit from the right-hand side, and dead on that point, it needs to be equal to this and this. Okay, that's the condition for it to be continuous. So looking at this function here, you cannot differentiate it at f here. You cannot differentiate f because this bit here is not continuous. You cannot differentiate it at e because this point here because this here is not continuous, and you cannot differentiate at d because this is not continuous. You cannot differentiate it at c because this point here is not continuous. Now these 2 points are continuous, but the thing is, you can differentiate this point, but you can't differentiate this point because this point here is it's smooth. Okay, so in order for you to differentiate at a particular point, it needs to be both smooth and continuous. This here is continuous, this here is continuous, but this point here is not smooth. So you can differentiate this point, but you can't differentiate this point here. Okay, well, smooth, roughly speaking, looking at this here, at A is kind of smooth, but if you look at point B, it's like there's a jump here, right at B. So roughly speaking, point A is smooth, but point B here, there is a jump, a sort of, well, it's not smooth here. It's smooth here. I will elaborate more on it later on. So here, suppose you have a graph and you want to differentiate it at x here. Remember, for us to differentiate it, we normally set up 2 points. The point we want to differentiate, which is this point here, okay, and then we set up a point on the right hand side, and then we drew a straight line here, a secant line here, and then as this point gets closer and closer to our x here, then it really becomes our true tangent line. Okay, that will give us a true gradient. But technically speaking, you really have to consider the negative side as well. So earlier we approached it from the right hand side. Technically you have to also approach it from the left hand side as well. So you see, when a curve is smooth, whatever that means, when it's smooth, you only need to approach it from one side, because they will both the tangent will eventually get to the same. You will eventually get to the same tangent line. But if you consider some, so remember, in order for you to work out the true gradient at a particular point, really you should approach it from both directions. So you need to approach it from the left hand side, and you also need to approach it from the right hand side. When it's smooth, it's okay. The two will meet up. But if you consider something like this, if you consider this here, okay, so let's say you want to differentiate it at this point here. This, by the way, you cannot differentiate. This you can, this you can't, because let's look at this. Let's say you want to try and differentiate this. So you set up another point. So you want to differentiate it at x0, let's say here. You would set up another point here, draw a straight line, and then get this point to approach your x0. And here, as it approaches x0, it doesn't really change here. But as it approaches x0, you can see the gradient. You can see the gradient here is negative, negative whatever. Okay. I know it's kind of weird because you're approaching from the right. But really, when you draw when you draw a straight line here, it's really a negative straight line. So this here is negative straight line. Okay, and then you also need to approach it from the left hand side. You see, so approaching it from the left hand side, you start at your x0 here, set up another point here, draw a straight line, get it to approach your x0. You see, this gradient here is not the same as the early gradient. This here is a negative gradient. This here is a positive gradient. So the two are not the same. In order for you to work out the gradient, the two gradients have to be the same. But clearly, when looking at this here, this gradient is not the same as this gradient. If you look at this point here, let's say x0 is here. You want to differentiate it at x0. So you set up another point here. Draw a straight line, and as you approach x0 here, eventually, hang on, x0 here, eventually you will get to a tangent line. Okay, eventually you will get to your tangent line. You see, eventually you will get to this point here. Now, even if you approach it from the left-hand side, let's say x0 is here, even if you approach it from the left-hand side, it will eventually get to the same point because it's smooth. Okay, eventually you will get to this, even if you approach it from the right-hand side, or if you approach it from the left-hand side, you will eventually get to this point. If you look at this one here, set up your x0 here, and then set up another point here. As you approach this, from the right hand side here, the gradient will eventually look something like this. Okay, and you can see that this gradient here is negative. Now, from the right hand side here, approach it from the left hand side here. When you approach it from the left hand side here, eventually your gradient will be something like this. You see, this gradient is different from this one here. So this point here is not, you cannot differentiate it here or here. But here, for some reason, because it's smooth, it will eventually get to the same gradient. But this one here, you will never. When you get to x0 and then you cross over, it suddenly flips. Your line, your two lines will suddenly flip. Whereas this one here, because it's smooth, there will come a point where the two sides equal. This one here will eventually flip. There will come a point where the two lines will flip. So this here you cannot differentiate because it's not smooth. This one here you cannot differentiate because it's not smooth. This one here is nice and smooth, so you can differentiate it. Okay.